So we're going to take a look at arithmetic sequences, which is section 1.1 of your textbook. We are going to take a look at what a sequence is, and then more specifically what an arithmetic sequence is. And then we're going to derive the general term for an arithmetic sequence. So a sequence is an ordered list of objects. It contains elements or terms that follow a pattern or rule to determine the next term in the sequence. The terms of a sequence are labeled according to their position in the sequence. So an example would be if you had the sequence 1, 2, 3, and then dot, dot, dot. And the rule to build this one is, as you can see, just by adding 1, right? So you go add 1, you go from 1 plus 1 to give you 2, add 1, 2 plus 1 will give you 3. And because you know the rule or the pattern, you know that the next number is going to be plus 1 again. And so 3 plus 1 is 4, and we can build our sequence that way. So we can build a sequence by either adding or subtracting a number. We can also build a sequence by multiplication or division. So for example, if we have 2 and then the next number is 4 and the next one is 8, you can see that we are building this sequence by multiplying by 2. So 2 times 2 is 4, 4 times 2 is 8, and so you know the next number is 8 times 2, which is 16, and you can continue building the sequence by multiplying by 2. So some things that we need to know before we move on. The first term of the sequence is T1, and the number of terms in the sequence is n. This is also considered the term number. Or if you like, the position in the sequence. The general term of the sequence is T subscript n, and this term, meaning the general term, is dependent on the value of n. Okay, now if we go over to the right here and just take a look at this section here, the first term of a sequence is sometimes referred to as a. You'll see that in some textbooks. Okay, or if you go online to look up more information on this, you'll see that some websites will use a for the first term. In this resource, the first term will be referred to as T1. That means in your textbook. T subscript n is read as T subscript n or T sub n. Okay, so if you have T1 like this, that means T subscript 1. So there are two kinds of sequences. You can have a finite or an infinite sequence. A finite sequence always has a finite number of terms. Okay, so for example, if we take a look at this first sequence, we've got 2, 5, 8, 11, and 14. You can see that you have 5 terms. Okay, and on our second example, you have 5, 10, 15, 20, then dot, 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 and they're telling you that the last number is 100. And because this is your last number, this sequence is finite. Okay, so the dot, dot, dot just means that you're not going to write all the numbers in between 20 and 100. An infinite sequence then has an infinite number of terms. So every term is followed by a new term, and there's no end to this one. So the example is 5, 10, 15, 20, dot, dot, dot. So this series of dots shows that the pattern continues forever. Okay, so arithmetic sequences then. An arithmetic sequence is an ordered list of terms in which the difference between the consecutive terms is constant. Okay, that means it doesn't change. In other words, the same value or variable is added to each term to create the next term. This constant is called the common difference. If you subtract the first term from the second term for any two consecutive terms of the sequence, you will arrive at the common difference. The formula for the general term helps you to find the terms of a sequence. This formula is a rule that shows how the value of t subscript n depends on n. So if we take a look at our definitions here, so common difference. The difference between successive terms in an arithmetic sequence can be given by this formula, d equals t subscript n minus t subscript n minus 1. The difference may be positive or negative. For example, in the sequence 10, 16, 22, 28, ... the common difference is 6. So let's take a look at that and our little formula here. So we have this sequence 10, 16, 22, 28, ... And you can see by looking at it that to build it, to go from 10 to 16, you would add 6. To go from 16 to 22, you would add 6. And to go from 22 to 28, you would add 6. And so to get the next number, you would add 6. So how do we use this formula? Well, the common difference is equal to t subscript n minus t subscript n minus 1. So let's say that this is t1, and the 16 is t2, and the 22 is t3, and the 28 is t4. And we're going to take a look at where n, and I'm just picking this arbitrarily, where n is equal to 4, let's say. Okay, and I'm going to substitute that into my formula. So d equals t subscript 4 minus t subscript 4 minus 1. So when we simplify, we get t subscript 4 minus t subscript n, 3. And so you can see that to calculate the common difference, you would take the t subscript 4, which is 28, and minus t subscript 3, which is 22, and then you would find that d is equal to 6. And you can do that for any of these terms. As long as the two numbers are consecutive, you're going to take the second of the two consecutive numbers and minus the first one from that. So 16 minus 10 is 6, 22 minus 16 is 6, 28 minus 22 is 6. Okay, the general term is an expression for directly determining any term of a sequence. The symbol is t subscript n. So for example, t subscript n can equal 3n plus 2. And this is a general term for a given arithmetic sequence. Okay, well that's only helpful for a given arithmetic sequence. Okay, what we're going to do on the next page is we're going to derive a general term and a general formula for all sequences, all arithmetic sequences. Okay. So we're going to derive the general term. We're going to use the example from the previous page, 10, 16, 22, and 28. Okay, as we discussed already, the common difference is 6 because we just add 6 to each term to find the following term. So we have a table here where the first column is the term number, okay, or the terms. So T1, T2, T3, T4, meaning the first term, second term, third term, and fourth term. Our sequence is 10, 16, 22, and 28. So T1 is 10, T2 is 16, T3 is 22, T4 is 28. And our third row is to write the sequence expressed using the first term and the common difference. Okay, and then for the last row, we're going to take a look at what the general sequence looks like. Okay, well the first column here is going to be easy enough. T1 is 10. You don't have to add any common difference to come up with T1. It's just 10, and so we're just going to call our first term generally T1. Now if we want to go from 10 to 16, then we add 6. Okay? And so if we want to write a general sequence for that, we can say, well, that's our first term plus our common difference. To build our third term, we take our first term and we add 6 to get the 16, and then I add another 6 to get the 22. So as a general sequence, that would mean I would take term 1 and I would add 2 times the common difference. And to build the fourth term, I'll do the same thing. I'm going to go 10 plus 6 plus 6 plus a third 6, and that will give me 28, and as a general sequence that would be our first term plus 3 times the common difference. So the general arithmetic sequence is T1 for the first term, T1 plus D for the second term, T1 plus 2D for the third term, and T1 plus 3D for the fourth term, where T1 is the first term and D is the common difference. And so we have that summarized here. T1 equals T1, T2 equals T1 plus D, T3 equals T1 plus 2D. So let's write that even in a more general way. Okay. What I'd like you to notice is that the coefficient in front of D, okay, is always 1 less than the term number, and the term number is right here, right? The third term is equal to term 1 plus 2 times the common difference. So the term number for T3 is 3. Okay, so what that means is we know that n is equal to 3. Okay, that's even true for T2 equals T1 plus D. It's understood that this coefficient in front of D is 1, and if you take a look at it, it's 1 less than the term number. Okay, my term number is 2, and the coefficient in front of D is 1 less than that. Okay, so we can generalize this formula even more. Okay, for any given term, T subscript n, I can find it by taking the first term and adding that to the term number minus 1 times the common difference. Okay. All right, so in general, the general term of an arithmetic sequence then is T subscript n equals T1 plus n minus 1 times D. Okay. It would help for you to memorize that. T1 is the first term of the sequence, n is the number of terms, D is the common difference, and T subscript n is the general term or the nth term. Okay, so there's a couple of ways that you can take a look at this general term. Okay, one way is as a let me redo that. Okay, the general term being T subscript n. Okay, one way to look at it is as the general term formula. Okay, that means T subscript n equals T1 plus n minus 1 times D. The other way to look at it is as the nth term. Okay, so the value of the nth term. Okay, and sometimes that's going to mean the last term in our sequence. Okay, so that concludes this discussion. So let's take a look at our first example. You are asked to write the general term and determine a particular term. So you are given the sequence -3, 6, 15, 24, ... Okay, meaning infinite. We don't know what the last term is, or there is no last term, right? It's infinite. Find the general term and find the 8th term. Okay, so to find the general term means to write an equation in the form of T subscript n equals mn plus b. That means that you want to start with T subscript n equals T1 plus n minus 1 times d. Okay? All right, so probably a good place to start with these kinds of questions is to list what you know. So I'll just write that down. Okay, and we have the sequence -3, 6, 15, 24, ... So one thing that we do know is that the first term, T subscript 1, is -3. And the other thing that we know is the common difference. Even though it's not given to us, we can calculate it. And we know that if we go 6 minus -3, or T2 minus T1, we will get 6 plus 3, which is 9. So we know our common difference is 9. Okay, and generally this is the information that we know, plus the fact, of course, that it's an infinite series. Okay, so the first thing that we're asked to do is to find the general term. Okay, that means that you're going to want to start with t subscript n equals t1 plus n minus 1 times d. Okay, now all we know in the general term is what t1 is, -3, and we know that d is 9. So we can start by plugging those in right away. So we're going to go t subscript n equals -3 plus n minus 1 times 9. Okay, and we're going to distribute the 9. Okay, now this right here is your general term, but we always simplify. So we'll distribute our 9. And we will go 9 times n is 9n, and 9 times -1 is -9. And then we will put in the form of t subscript n equals mn plus b. Okay, so that's equal to, we put our variable term first, 9n, and then -3 minus 9 is -12. And so this is your general term. Okay, the second thing we've been asked to do is to find the 8th term. Okay, and we can use our general term to work that out. Okay, now because they want you to find the 8th term, they want you to find t subscript 8. That's the nth term. Okay, and because we're looking for t subscript 8, we know that n is equal to 8. So we're looking for the 8th term. We're going to use our general term for this specific sequence. Okay, so we write out our formula, t subscript n equals 9n minus 12. Now we've determined that because we want to find t subscript 8, that n is 8, so we can replace the n with the 8. And then we work this out. 9 times 8 minus 12 gives us 60. So 60 is the 8th term. So example 2, determine the number of terms. So find the number of terms n in the following sequence: 13, 7, 1, ... -119. Assume the pattern is constant. Okay, so you're being asked to find the number of terms, which means you want to find the value for, you want to find the value for the variable n. So just like on example number 1, let's list what we know. Okay, we know that t1 is 13. We aren't given d, but we can calculate it. We can calculate it by going 7 minus 13. And that gives us -6. And the other thing that we know is that the last term of our sequence is -119. Okay, now we don't know how many terms there are in our sequence, so we're going to call this t subscript n. Okay, remember that's the nth term of our sequence. Okay, so t subscript n is -119. Okay, and what do we want to find? We want to know what n is. Okay, so we're going to use the general term. Okay, the formula, so t subscript n equals t1 plus n minus 1 times d. All right, and looking at the information that we have over on the left, we know that t subscript n is -119. We know that t1 is 13. We don't know what n is, but we do know that d is -6. Okay, so we're going to take this equation that we have now, and we have the only variable is n, so we're going to solve for n. And the first thing we want to do is we want to distribute the -6. Okay, so we're going to go -119 equals 13, and then -6 times n is -6n, and -6 times -1 is +6. And then we will combine our like terms on the right-hand side of our equation, 13 plus 6, okay, and that's going to give us 19. Okay. And then we'll bring our 19 over to the left-hand side. It becomes negative. And we're going to go -119 minus 19, which is going to give us -138. And then divide both sides by -6. And you get that n is 23. And so there are 23 terms in this sequence. Example 3, using what you know. We're going to take a look at two examples here that are similar to each other. In the first one, you're asked to find three numbers that when placed between 22 and 74 make an arithmetic sequence. So what that looks like is our first term is 22, and we've got three numbers in between that and 74. So I'm going to use spaces to indicate our three numbers. And so you've got a sequence that has 5 terms, okay? So here's T1, T2, T3, T4, and T5. So as in our previous examples, the first thing you should do is to write down what you know. And we know that n is equal to 5, okay, because we've got 5 numbers in this sequence. We know that T1 is 22, and we know that T subscript 5 is 74. So let's start with our general term. We know that that is Tn equals T1 plus n minus 1 times d. And let's plug in what we know. We know that we have 5 terms, okay, that n is 5 terms in this sequence. So that means that I can plug a 5 in for n here, and that would mean T5. And we know that T5 is 74, so I'm going to replace T subscript n with 74. T subscript 1 is 22. And we know that n is 5, so we plug that in for n. And then times d. Now if you take a look at what we have here now, this equation, it looks like we're finding the variable d. And so that is really going to be our first step. Okay, and it makes sense that we want d because in order to build our sequence to go from 22 to 74, I need to know what the common difference is, right? I need to know what to add to 22 to get T2, what to add to T2 to get T3, and what to add to T3 to get to T4. Okay, so we're going to solve for d here. We'll start by simplifying what's inside the bracket. Okay, and 5 minus 1 is 4, so that leaves us with 4d. We want to isolate for d, so the first thing that needs to move over is our 22. Bring it to the other side, it becomes negative, and 74 minus 22 will give you and me 52. So 52 is equal to 4d. And now we want to solve by dividing both sides by 4, and so we get that d is equal to 13. Okay, so now we can find our other 3 terms, okay? And according to our diagram here, we're looking for T2, T3, and T4. Okay, to get T2, we want to take T1, which is 22, and we want to add our common difference to that. So 22 plus 13, which is 35. And so we know that T2 is 35. To get T3, you want to take T2, which is 35, and you want to add 13 to that. And 35 plus 13 is 48. And so we know that T3 is 48. And to get T4, we want to take T3, which is 48. We want to add 13 to that, and we get 61. So we can see that T4 is 61. So the three numbers that we've been asked to find are 35, 48, and 61. Okay, so our second example here is similar to that, except that our unknown numbers are not in between two given numbers. Okay, so we still want to start by writing down what we know. Okay, and in this sequence we've got space, space, 4, space, -2, -5. We've been asked to find T1 and D. And so what we do know is, first of all, that n is equal to 6, right? Because we've got space, space, 4, space, -2, -5. So 1, 2, 3, 4, 5, 6. So n equals 6. We know that our last term is -5, and our last term in this particular sequence is going to be t subscript 6, right? Because we know that n is 6. And so that is -5. And we're going to calculate d because we have two numbers that are consecutive, -2 and -5. So if I go -5 minus -2, that's going to give me -5 plus 2. And so d is equal to -3. Okay? All right. So we know what d is now. We've been asked to find d, so we have that. Now we're going to find T1. We'll use our general term to find T1. All right, so T subscript n equals T1 plus n minus 1 times D. I know T subscript n because I have the last term in my sequence, which is -5. So it's actually T subscript 6, so that would give me -5. Don't know what T1 is. I know that n is 6, and I know that D is -3. Okay, and as you can see, we're going to be looking for T1. So let's simplify our equation. Inside the bracket, I have 6 minus 1, which is 5. So I'm going to times that by -3. And 5 times -3 is -15. And I'm going to move that -15 over to the left, and it becomes positive. So I see that T1 is going to be -5 plus 15, which is 10. Okay? And so the common difference is -3, and the first term is 10. Example 4, graphs of arithmetic sequences. So we're going to take a look at the graph of an arithmetic sequence. Before we do that, I just want you to know that arithmetic sequences are linear functions. That means that when we graph, we should get a straight line. And another thing that I would like you to do is just to recall our general term from example 1. We got t subscript n equals 9n minus 12. And I just want you to compare that to the slope intercept form of an equation, which is y equals mx plus b, and see if you can see some similarities. Okay, the format is similar, right? You have a variable equal to a coefficient times a variable plus or minus a constant. Okay, same format as y equals mx plus b. If you take a look at both equations or formulas, you will see that the t subscript n and the y are in the same position. And you will see that the n and the x are in the same position. Okay, so this does give us some information. If our general term is indeed in the form of y equals mx plus b, then t subscript n gets graphed on the vertical axis, okay, and it's our dependent variable. And our n, which is in the same position as the x in y equals mx plus b, gets graphed along the horizontal axis, and so that makes our n the independent variable. Okay, and one other thing just to remind you from last year's grade 10 math, anything that's graphed on the horizontal axis is your domain, and anything graphed along the vertical axis is your range. Okay, so if you take a look at the graph that we have here, our terms, okay, t subscript n, whatever our term number is, it's graphed on the y-axis, and the nth term is graphed along the x-axis. So for our first question, what are the first three terms? Well, if you take a look, our first three terms are here on our graph, okay? And your term is graphed on the y-axis, so you would expect that the y-coordinate for each of these points would be a term number, okay? So if we get the coordinates for these first 3 points, then we should get the first 3 terms, okay? So our first point is where x is 1 and y is -2. Our second point, x is 2 and y is 0. And our third point, x is 3 and our y-coordinate is 2. And so you can see from this that our first 3 terms are -2, 0, and 2. So the next part of the question asks you to write the general term of this sequence. Now all you need to know in order to write the general term is what T1 is and what D is, okay? And we know that T1, okay, according to our graph and according to what we determined in part A, is -2. And we can calculate D because we have consecutive term numbers, so I can just go T2 minus T1, so 0 minus -2, which gives me 0 plus 2, which is 2. And so T1 is -2 and D is equal to 2, and we have enough information to come up with our general term now. Now just recall, when they ask for the general term, they're asking for the formula, which means you want to start with t subscript n equals T1 plus n minus 1 times D. So t subscript n equals -2 for T1, n minus 1 times 2 for D. We want to simplify as much as we can, so we want to expand. And so we get t subscript n equals -2. 2 times n is 2n, and 2 times -1 is -2. Combine your like terms, -2 and -2, and you get that t subscript n equals 2n minus 4. Okay, so there's your general term. And they want you to calculate what T50 is and what T200 is. Okay, well let's start with T50. if you're asked to find t50, then you can tell from this that n is equal to 50. So if we use our general term, t subscript n equals 2n minus 4, we're going to plug in 50 for n. And so we get t subscript 50 equals 2 times 50 minus 4. And that gives us 100 minus 4. So t subscript 50 is 96. And then for t subscript 200, we can see that n equals 200. So we start with our general term, plug in 200 for n, and we get that t200 is 400 minus 4, so t subscript 200 is equal to 396. So the last two parts of this question ask you to compare the slope of your graph with your formula and the y-intercept of your graph with your formula. So let's start with finding the slope, because we need to compare that to our formula. So describe the relationship between the slope of the graph and your formula from part B. So we go to our graph, and we know that slope is rise over run, so we can see from our graph that our rise is 2 and that our run is 1. Okay, and because we have to determine whether our slope is positive or negative, if we start at our first point and we move to the right, we know that that movement is a positive movement, so our run is positive 1. And then we want to go up 2 units, so that is a positive movement also, going up, and so our rise is positive 2. Even if I were to go from our second point to our first point and I would go down to, that would be negative 2. Okay, so I'll just put that over here. And if I go to the left 1, that would be negative 1. So my rise would be negative 2 and my run would be negative 1. I'm still going to get the same slope, okay? And if you recall from last year, the slope, m is equal to rise over run. Okay, and our rise is 2 and our run is 1, so that gives us 2. Even if we went that our rise over our run is negative 2 over negative 1, I would still get positive 2, because a negative divided by a negative is a positive. Now we've been asked to compare this slope with our formula, so let's take a look at our formula, which is t subscript n equals 2n minus 4. And we know this is in the form of y equals mx plus b. And if you recall from last year, m is your slope. And so if you take a look at our formula, it's mx and 2n. And so you can see that the slope of our graph, which is 2, is the same as the coefficient on the n. So the slope of the graph is 2, and the coefficient of n is 2, and so they are the same number. Okay, and something else that I would like you to note, okay, and I'll just write that over here, is that the coefficient of n, okay, which is 2, is also your common difference. Okay, notice that over here. Okay, we got a common difference of 2, and our slope is 2, and the coefficient on n is 2. So notice that the coefficient of n is the common difference. So the last thing you've been asked to compare is, or to describe, is the relationship between the y-intercept and your formula from part D. Now, if you take a look at your graph, if I were to draw a line through here, okay, my y-intercept would be at -4. Okay, so from the graph, the y-intercept is -4, and the constant of the general term, okay, which is t subscript n equals 2n minus 4, is -4. Okay, and they are the same number. All right, so your y-intercept of your graph is the same as the constant of your general term. Example 5, word problems, or if you like, application problems. We're going to take a look at 2 of them. And in the first one, the musk ox and the caribou of the northern Canada are hoofed mammals that survived the Pleistocene era, which ended 10,000 years ago. In 1955, the Banks Island musk ox population was approximately 9,250 animals. Suppose that in subsequent years, the growth of the musk ox population generated an arithmetic sequence in which the number of musk ox increased by approximately 1,650 each year. How many years would it take for the musk ox population to reach 100,000? Okay, so let's write the sequence down, okay? We know that in 1955 our starting population was 9,250. And we know that in each subsequent year the number of musk ox would increase by approximately 1,650. So that means we want to add 1,650, and so in the following year we would have 10,900. And then if we add another 1,650, we would get 12,550. And if we add another 1,650, then we would get 14200, and we want to find out how long it takes to get to 100,000. Okay? Okay, so there's a lot of information that we have gotten from our problem. Okay, number one, we know that, so what we know that T1 is 9,250. We know that our common difference is 1,650. We also know that our last term, okay, the nth term, is 100,000. Okay, and so if we go to our general term, which is t subscript n equals t1 plus n minus 1 times d, and we plug in what we know, so t subscript n is 100,000 and t1 is 9,250, and we don't know what n is, and we do know that d is 1,650, you can see by looking at our equation that we're looking for n, and so n must be the number of years. Okay, so let's calculate what n is. So the first thing we want to do is distribute our 1650. So we get 100,000 equals 9,250 plus 1,650n minus 1,650. We want to combine our like terms, so 9,250 minus 1,650, and we get 7,600. We want to bring our 7,600 over to the left. It becomes negative, and so 100,000 minus 7,650 leaves us with 92,400. And that's equal to 1650n. We want to divide both sides by 1650, and we get 56. And so it would take the musk ox population years to grow to 100,000. So our second application problem for example 5. Jonathan has a part-time job at the local grocery store. He has been asked to create a display of cereal boxes. The top 6 rows of his display are shown. The numbers of boxes in the rows produce an arithmetic sequence. There are 16 boxes in the 3rd row from the bottom and 6 boxes in the 8th row from the bottom. You've been asked to find 3 things. How many boxes are in the bottom row? Determine the general term t subscript n for the sequence, which means to find the formula. And 3, what is the number of rows of boxes in his display? Okay, well the first thing you need to understand is that when Jonathan is building this display, he's starting from the ground and going up, okay? So if we draw that this is the ground, then you can see that as he builds his display, the number of cereal boxes decreases. Okay, and what else can we get from this picture? First of all, because he's starting on the ground, we know that that's where T1 is. Okay, so the number of the first term of this sequence will be the ground floor. Okay, and so you'll have more boxes for T1 than you would if you were building, if you go up the diagram. Okay, and so we would go from T1 up to t subscript n, which we know from our diagram is 2. Okay, and what else do we know? We know that there are 16 boxes in the 3rd row. Okay, so for the 3rd row, we have 16 boxes. So that means that T3 is 16. And we also know that the 8th row from the bottom is 6 boxes. So if we go to our diagram, that's right here. So this is the 8th row, which means that this is t subscript 8. Okay? And the other thing that we can gather from our diagram is that because the number of boxes is decreasing as we go from T1 to Tn, D must be a negative number, right? Because we are losing boxes with each row. And so one way to calculate it is, I know that my top row is 2 and my next row is 4. And so if I want to calculate D, I'll take I take 2 minus 4 to get negative 2. Okay, and I know it's negative because the number of cereal boxes is decreasing, so that's why I need to know, that's why I know that I have to go 2 minus 4 to get the negative 2. Okay, so for our first question, how many boxes are in the bottom row? Write down what you know. Okay. You know that the common difference is negative 2, because we just worked that out. We know from the problem that T3 is 16, and we also know that T8 is 6. The other number that we know is that T subscript n is 2. All right, and what are we looking for? We are looking for T1. So we're going to start with our general formula. And you might think by looking at this formula that you do have a value for T subscript n, 2, and that you could probably plug that into here, except that there's one problem. You don't know the number of rows. So it's not going to be useful to use T subscript n from the problem to figure out what T1 is. Okay? It would be better to use T3 being 16 or T8 being 8. Either one of them will give us the information that we need to figure out what T1 is. And I'm going to use T subscript 3. Okay. And if I use T subscript 3, then I know that n will equal 3 for this. And of course, T subscript 3 is 16. And I'm going to plug these in. Okay. So if n is 3, then I need to plug in a number for T subscript 3, which I know is 16. And I've got T1 plus, and I know that n is 3. And then times my common difference, which is 2. And so you can see now that the only variable I have remaining is T subscript 1. And so that's what I will be solving for. So the first thing I want to do is I want to simplify what's in the bracket. So 3 minus 1 is 2. Okay, and so now I've got 2 times negative 2, so I'm going to multiply that out. And 2 times negative 2 is negative 4. And I want to solve for T1, so I'm going to bring the negative 4 over to the right, or the left. It becomes positive. 16 plus 4 is 20. And I can see that in the first row, there are 20 boxes. Okay, so the second part of the question is to determine the general term for the sequence. Now remember, the only information that you need for the general term is what T1 is, which we know is 20, and what D is, which we know is negative 2. And so we will start with T subscript n equals T1 plus n minus 1 times D. And so T subscript n equals 20 plus n minus 1 times negative 2. Distribute the 2. T subscript n equals 20 minus 2n plus 2. Combine your like terms, and you get that 20 plus 2 is 22. And so T subscript n equals negative 2n plus 22. Okay, and the last thing you've been asked to calculate is what is the number of rows of boxes in this display. Okay, and so we're going to use our general term to find this out. Okay, so what information do we know in order to calculate the number of rows? Okay, well, it would be useful for you to know that the number of rows is going to be the value for n. So we're going to let n be the number of rows. Okay, and so that means we're looking for n. So we should have a value for T subscript n, which we do according to our diagram. We know that T subscript n is 2. And so I can use that now to find out what n is. Okay, so t subscript n equals 2. I'm going to plug that in for t subscript n in my formula. Going to solve for n, so I got to bring the 22 over to the left. It becomes negative, and 2 minus 22 is negative 20. Divide both sides by negative 2, and I find that there are 10 rows in the display.